Continuing on from our previous video, we're looking into the particular symbology and understanding of Venn diagrams. So we've already covered A unified with B, and we said that we could interpret this as A or B. We had A intersect with B. We interpret that as A and B. Okay, and when we graph those, I hope you can flip back to the previous video and see what these look like. The two that we're going to be covering now are not A intersect with B, and I'm going to put it on this side because I'm going to do it over here, and A intersect with not B. Before we go on, we need to understand what this looks like, not A and not B. So if we take for example a scenario. It doesn't really matter what the survey is or what we are measuring. Let's say we have some sample space, and we have some group within the sample space. Okay, so this is group A. If we wanted to calculate the probability of A happening, we would count all the elements inside of A. So if we calculate probability of A, we would just count the inside of this. But if we were to calculate the probability of not A, so of A not happening, well then wouldn't it be the counting of everything that's not inside A? So if shading in this, the circle, is counting all of the elements in A, counting of all the elements not in A would be everything outside of it, wouldn't it? Not A. So this is what it looks like in terms of the Venn diagram. But now we're going to look at what it would mean for not A intersect with B and A intersect with not B. And we're going to go back ultimately back to this one here. So let's take a look into A intersect not A intersect with B. So here we have our sample space and our two groups. Well, if we were to, here are two groups, A and B, and we're going to shade A, not A, intersect with B. Well, earlier we saw that this could be replaced with not A and B. We could replace it with that. Well, let's shade everything that is not A first. Let's take a look. Well, if A is that circle there, okay, everything that's not A, we would shade around it. Okay, we would shade everything around it because we want to keep A clear. But it said, so that's not A. But we want and B. Well, if we shade everything, which of what we shaded is also inside B? Well, it would be that region there, the region that contains only B. So ultimately this could be also interpreted as only B. I know it's a very complicated way to show what we've already graphed up here. So in terms of this, in our Venn diagram, not A and B is 11. Because if we said not D, so if we did, do it down here, if we did not dogs and cats, okay, if we wanted to count how many are in this group, we could say it's only cats, only of these that are cat owners, but we already have it here. It's 11. We did this by just calculating it using the Venn diagram. So only cats, well, there are 11 only cat owners. Well, I hope you can sort of see where this is headed towards now. Well, if not A intersect with B looks like this, well, A intersect with not B, well, wouldn't that be almost exactly the same? So here's our group A, and here's our group B. Wouldn't that only be this region here? Because we said that not A intersect with B is the same as only B. Therefore, A intersect with not B is the same as only A. Only A. So if we brought this down to our example, if they wanted dog owners and not cat owners, that's the same as only dog owners. Okay, only dog owners. Well, we've already calculated again. There are 16 owners that are just dog owners. So there's our answer. 16 only dog owners. So now what's the whole point of this here? Well, the whole point of understanding these terminologies is now that we understand these, let me just quickly copy this out again. If we had, there's our dog owners, there's our cat owners, there's 4 here in the middle, 16, 11, and 9 that are neither. Okay. If now we were asked to, let's say, calculate, do it in red for questions. If they asked us for question A, calculate the probability of dog owners. Well, let's think about that. How many are in the group of D? Well, if you said 16, you're incorrect, because that 4 is also part of it, because there's no conditions on this event. It just says dog owners. Well, there are 20 dog owners, and there are 40 people in total. Whoops, sorry, I didn't add that, but we got that from the previous one. There are 40 total, which gives us a probability of half. But if the question asks, let's say calculate the probability of A unified with B. Oops, sorry, it shouldn't be A. It should be D unified with C. Well, Now we know that D unified with C, that's the same as probability of dogs or cats. And we also saw that that interprets graphically, going back to this, as everything that's shaded in those two groups. Well, if it's everything that's shaded in this group here, it would be 16 plus 4 plus 11, which gives us 31 out of 40. And we could go on like this. We could calculate all the different variations of things that they want from us. So if they wanted, for example, question, they calculate the probability of not A and or intersect with B. Well, we already know this one because it says it's the same as probability of only B. Oops, sorry. Well, it shouldn't be A. I'm getting a bit confused. It's not A and C, it's not D and C. Well, that's the same as only cat owners. Well, how many of these are only cat owners? Well, you can't include that 4 because that 4 are also dog owners as well as cat owners. So we really only want this 11 here. There's 11 out of 40. I hope that clarifies a few things about Venn diagrams.